Hello, today we're going to be starting on our Unit 4, parent graphs. Today we're just going to start with parabolas in vertex form, which is something we have discussed before, kind of started into it at some, but we didn't go too far with it. So we're going to get into it a little bit better today, so hopefully anybody who has struggled with that can figure that out a little bit better. So to start off, we're going to look at our regular parabola. We start by putting this in our table. There's some quicker ways to do this, but this is what's called our parent graph. And that is the most basic parabola we can get. We're going to do a lot of other parent graphs as we go through this unit, but we're just going to start with the parabola because it's familiar. With any graph, we can put in a number and evaluate to get the y value. So if I have y equals x squared, I'll put y equals -3 squared, that's going to give me 9. Y equals -2 squared, that's going to give me 4. Remember, a negative squared is always going to give you a positive. -1 squared is going to give me 1, 0 squared will give me 0, 1 squared will give me 1, 2 squared will give me 4, and 3 squared will give me 9. So when I graph this, I graph starting at 0, 0, -3, up 9, and make my point. Nope, that's not where I want it. -3, up 9. Next one, -2, up 4. -1, up 1. 0, 0, 1, 1. 2, 4, and 3, 9. And that's our parabola. So the parent graph of the parabola has a pretty specific pattern that we've talked about a few times. And that is from our locator point, which in this case is our vertex, we go out 1 and up 1, out 1 and up 3, out 1 and up 5. If we were to continue, that would be up 7, up 9, so on and so forth. So our vertex on this is the point 0, 0 for our parent graph. And now what we're going to be doing, and this was an investigation, which is, I think, quite helpful to this process. So if you're just watching the video, hopefully you've also done the investigation or you plan on doing that. It will help a lot. The graphing form is y equals a times x minus h squared plus k. And the vertex is our h, k parameters. So when we're going to talk about this form today in terms of what a does, what h does, and what k does. But for the parabola, hk, that's our vertex, our locator point. We're just going to use them interchangeably today. So we also want to think about if we have just our parent graph equation, the y equals x squared, what are the values of a and h and k? So if I think about this in terms of y equals, a is being multiplied here, a times this x minus h squared. So if this is really what it's supposed to be, there's no change in what a is. The number that I can always multiply by things without changing them is the number 1. So we have 1 times x minus, and then here, you can't see where I'm pointing, sorry. Here, my hk, as it was on the last slide, is going to be a vertex of 0, 0. And so that means that my h is 0 and my k is 0. So this is going to be x minus 0 squared plus 0. So that's the most basic version if I put it in that vertex form. And that's what I wanted to point that out for, is that sometimes we have something like y equals x minus 2 squared, and there is no plus k hanging out there, so that means our vertex would be, 2, 0. Or if I have y equals, that's not what I meant to do, y equals x squared plus 3, that would have a vertex of 0, 3. So some of those are a little bit different than what they look like in this form here, but it's just because we have something else, like a 0 as a placeholder or a 1 as a placeholder. We'll talk more about that in a minute. So the investigation that I gave the class to do for this particular lesson goes through some really helpful little exercises and actually seeing how these parabolas move around the graph. And what it comes down to, this is kind of our close in the class, is the different parts and what they do. So first off, we have the h value. And h moves the parabola, or moves the locator point, left or right. Now, I'm saying locator point instead of vertex because as we get into the chapter, this is for a parabola. That squared tells us this is a quadratic. It's for a parabola. We're also going to get into cubics, where that would be a 3. We're going to get into square roots, where we'd have the square root over it. Absolute values. We're going to get into different parent graphs. And so the HK remains a locator point. And with all of those, h moves the graph left and right. So for example, still want to be here. If I have y equals x minus 3 squared, that would move the parabola 3 to the right. No, wow. So that would be the point 3, 0. Now, this is where it gets a little bit confusing because this is x minus. That's part of the form. So what's ever in place here, like right here, x minus, that's also not what I wanted. Sorry. This is x minus 3. So it's really just the 3 that's in place of the h value. So the thing, and we'll do one more here. So y equals x plus 2 squared. That's going to take my parabola from middle, and it's going to move it 2 to the left. So this h value is actually going to be negative 2. Negative 2, 0. So the h is actually negative 2 because that would have to be x minus a negative 2 squared to make that a plus. And I'm going to erase that so it doesn't get too messy. So the thing I want you to add to this, the h value pretty much moves it in the opposite direction of what you would expect. So if it's x minus, it moves it to, wow. Sorry, just getting back from Thanksgiving break, and I'm a little off today. So it moves it the opposite direction of what you would expect. X minus 3, that moves it to the right. X plus 2 moves it to the left. So then, so h is whatever is bundled in there with x. In this case, it's parentheses squared. K is the one that's hanging out by itself. K moves your graph, or moves your vertex, and I'm just going to put LP for locator point, up or down, and that moves it exactly the way that you would think it was. If it's a plus K, it moves it up. If it's a minus K, it moves it down. And I'm going to put a line in here. Let's separate those two off. Up a little bit. There we go. Sorry about that. Okay, so if I have y equals x squared plus 3, it's going to take my graph and move it up 3. And this is just a rough sketch. So that would be the point 0, 3. If I have y equals x squared minus 5, that's going to be negative 5, it's just going to move that down 5. So that would be 0, -5. So that is that part. Now, the last one, there's a lot of ways to describe what the A value would do. But there's kind of a simple way to think about it. In all of our parent graphs, with the parabola as our first example, it goes over 1 to the right, so right 1 and up 1. And it turns out that actually all of our parent graphs do that. It goes over 1 and right 1. The pattern from there changes a lot. It doesn't continue to go over 1 and right 1, or right 1 and up. Wow, I just said that totally wrong. Right 1, up 1. Right 1, up 1. Sorry. So the parabola, as you know, goes 1, 3, 5 after that when you go out 1. But all of our other parent graphs, that first step, if A is 1, is going to go right 1 and up 1. So what A does, it tells you where to go after you go right 1 from the locator point. And this will become more clear after a couple of examples. But if I have y equals 2x squared, normal parabola, that would start at 0, 0, and I would go right 1 and up 1. And instead, I'm going to go right 1 and up 2 on both sides because this is a parabola. And so the way, whoops, that's really messy. The way this affects a parabola is basically each of those steps, that 1, 3, 5, gets multiplied by 2. If I have y equals -x squared, that's an A equals -1. I'm going to start at 0, 0. I'm going to go right 1, and I'm going to go down 1 instead of up 1. So whatever A is, it tells you go right 1, and then whatever the A value is, that's what you do. If it's negative, you go down. If it's positive, you go up. If it's 1/2, you only go up 1/2. So the pattern after that initial move, so like you go right 1 and up 2 for this one. After that, you have to be careful about what that pattern does. But that A value, that's a good starting point for figuring out what that is. And if you're ever in doubt, always plug in numbers. Like just plug in an X value and see what you get for Y. Okay, so let's do some examples. This is a little bit fuzzy. I do apologize. So the first thing we need to do is figure out, this is a quadratic because this is what we're dealing with, a parabola. We want to figure out what is in place of X and what's in place, what's in place of H, what's in place of K, and what is in place of A. Wow, I cannot write today. So A would normally go here. There's nothing there, so that's an implied 1. H is right there. Thing to note, the X minus is the same in both of these. So H is actually just 3. And then K, because that's negative, K is -5. So we have a vertex here, or a locator point, of 3, -5. So I'm going to go over 3, down 5. My A value is 1, so I'm just going to go out 1 and up 1 in both directions. Out 1 and up 3 in both directions. Out 1 and up 5 in both directions. And that's about enough. I don't need to keep going. I can. 1, 3, 5, 7, so on and so forth. But that's how I draw that parabola. You want to make sure that you're really clear about these points that I'm highlighting, kind of the first 3 points. It's easy to screw up and get your lines in the wrong place. Like you can tell on mine, I kind of missed the point here and missed the point here, but the points are where they're supposed to be, and that's what I grade when I grade these tests. So another example is another fuzzy one, apparently. When I'm looking at a graph, I need to figure out a few things here. So the first is my vertex. That gives me my H and my K. So the vertex is 2, 3. Then I need to figure out what my A value is. So remember we went, what I told you was what happens when you go right 1. So I go right 1, and then I'm going down. So I know this is negative, and I'm only going halfway. So this is an A value of -1/2. So that's A, that's H, and that's K. So when I write this in, y equals -1/2 x minus, and then my H value is 2. Don't forget the squared, and then my K value is 3, so plus 3. And that's my equation. So that's it. I'm not going to spend much more time on this, for the video at least. But hopefully that'll help you out. And if you, I would definitely recommend you get that investigation and complete that investigation. That helps a lot with the process. It kind of builds it together. We're going to be working on completing the square to get things in vertex form next class. And then the class after that, we're going to be doing the other parent graphs. So this is a good foundation for what we're going to be doing the next couple of classes. Hopefully that helped, and I hope you have a good day.